number 7 is actually one of my favorite concepts in physics because you can actually apply it to the real world. It says a 100-meter length of steel, so it tells us we have an original length of 100 meters, changes temperature by 30 degrees Celsius during the course of a day. So we have a change in temperature equal to 30 degrees Celsius. If the coefficient of thermal expansion of steel is 12 parts per million, so the coefficient of thermal expansion is alpha, and it's equal to 12 parts per million per degree Celsius. What is the change in length of the steel? So we're looking for the change in length. So the reason I like this question is you can apply it to the real world. Those bumps that are on bridges, when you hear the thudding when you're driving across them, those are actually using this concept. Bridges expand and contract throughout the day during hot and cold periods, so the concrete doesn't crack, it actually expands, and they need to know how much it expands. The other way you would see this question is volumetric. Say you have a container of gasoline and you just filled the gas up when it was very cold out, and in the middle of the day the temperature rises 30 degrees. Well, the volume is going to be greater, and that's why you have to vent those the air caps on the volume containers, on the gas containers, because the pressure and the volume both increase when the temperature increases. So, to get down to this question, we have the formula: change in length is equal to the original length times the alpha coefficient times the change in temperature. Notice here, we have 12 parts per million per degree Celsius, and we have 30 degrees Celsius. Therefore, we do not have to convert into Kelvin. So, let's go ahead and plug everything in. 100 meters. Now, if you're a little bit confused, 12 parts per million is just equal to 12 times 10 to the minus 6 per degree Celsius. It's times 10 to the minus 6 because it's for every million you have 12 parts. And then we have times 30 degrees, and that is equal to our change in length. And when we go ahead and do this on the calculator, we do 100 times 12 times 10 to the minus 6 times 30. We get 0.036 meters. And we look at our answer choices, and choice number 1 says 3.6 centimeters. So if you multiply that by 100, we have our 3.6 centimeters. Now, another way you can see this is, like I said, with a gasoline container, and you fill it up with a volume. So you would have the volumetric change. Change in volume is equal to the original volume times the beta coefficient times the change in temperature. So Dr. Sullivan can ask you for any of these variables, and all you have to do is basically plug them in, and remember, keep the units of Celsius the same and know how to convert parts per million. So in this case it was 12 times 10 to the minus 6.